lesson, let's have geometric sequence. For our learning objectives, after going through this lesson, we will be able to illustrate geometric sequence, determine the end term of geometric sequence, state whether the given sequence is geometric or not. Let's define first what is geometric sequence. It is a sequence where every term after the first is obtained by multiplying a non-zero constant called the common ratio. Common ratio denoted by R is the constant number multiplied to the preceding term of the geometric sequence. It can be calculated by dividing any two consecutive terms in the geometric sequence. The formula is common ratio is equal to a sub 2 divided by a sub 1 equals to a sub 3 divided by a sub 2 equals a sub 4 divided by a sub 3 and so on and so forth. If we have 1, 3, 9, 27, 81, and 243, we can get the common ratio by dividing the preceding term. So if we have 3 divided by 1, we have 3. 9 divided by 3, we have 3. 27 divided by 3 is 3, and so on and so forth. So our common ratio is equivalent to 3. Let's try to answer this. Geometric or not? Determine whether the following are geometric or not. Yes, find the common ratio. Click the heart button if it is geometric and like if not. Are you ready? Let's start. Number 1. 1, 5, 9, 13, 17. Geometric or not? Very good. Not. Number 2. 1, 2, 4, 7, 11. Geometric or not? That's right. The answer is not. Number 3. Negative 2, negative 4, negative 8, negative 16. Geometric or not? Very good. The answer is geometric and common ratio is 2. Number 4. 2, negative 8, 32, negative 128, 512. Geometric or not? That's right. The answer is geometric and the ratio is negative 4. Number 5. 15, 75, 975, 1875. Geometric or not? Very good. The answer is geometric. Ratio is 5. Find the nth term of the geometric sequence, use the formula. A sub n is equal to a sub 1 times r raised to n minus 1, where a sub 1 is the first term, n is the number of terms, r is the common ratio, and a sub n is the nth term. Let's have illustrative example number 1. What is the next term of the sequence 8, 24, and 72? The given are the first term or the a sub 1 is equivalent to 8, the second term which is 24, and to get the common ratio, divide a sub 2 divided by a sub 1. So we have 24 divided by 8, the common ratio is equivalent to 3. Use the formula, so we have 8 times 3 raised to 4 minus 1. 3 raised to 4 minus 1 is equivalent to 27 times 8, so we have 216, or we can simply multiply the value of a sub 3 or the third term by its common ratio, so we have 72 times 3, the answer is 216. Let's have illustrative example number 2. find the 8th term of the geometric sequence 7, 28, 112, 448, and so on. The given are a sub 1 is equivalent to 7 or the first term. Common ratio is equivalent to 4 because 28 divided by 7 is 4 or 112 divided by 28 is 4. Then we have the n which is equivalent to 8. Then we need to find the a sub 8 or the 8th term. Using the formula, substitute the value. So we have a sub 8 is equivalent to 7 times 4 raised to 8 minus 1. So we have 8 minus 1, we have 7. So we have 7 times 4 raised to 7 is equivalent to 16,384. Therefore, 7 times 16,384, we have 114,688. Next example. Find the common ratio in the geometric sequence if the first term is 3 and the 8th term is 384. The given are a sub 1 is equivalent to 3, a sub 8 is equivalent to 384, n is equivalent to 8, then we need to find the common ratio. Using the formula a sub n is equivalent to a sub 1 times r raised to n minus 1, substitute the given value. So we have 384 equals 3 times r raised to 8 minus 1. By applying the property of equality, we can divide both sides of the equation by 3. So we have 384 divided by 3 is 128. 3 divided by 3 is equivalent to 1 times r raised to 8 minus 1 is equivalent to r raised to 7. To find the value of the common ratio, we can get the 7th root of both of the equation. So we have the 7th root of 128 is equivalent to 2, and then the 7th root of r raised to 7 is equivalent to r. Then the value of r is equivalent to 2. Let's have another example. Insert two geometric means between 3 and 180. The terms between any two non-consecutive terms of a geometric sequence are known as geometric means. So we have 3, blank, blank, and 180. Given are a sub 1 equals 3, a sub n equals 192, n is equal to 4, and we need to find the a sub 2 and a sub 3 for the geometric means. Using the formula, a sub n equals a sub 1 times r raised to n minus 1, substitute the given value. So we have 192 equals 3 times r raised to 4 minus 1. By applying the property of equality, we can divide both sides of the equation to 3. So we have 64 equals r cubed. To find the value of r, we can get the cube root of both sides of the equation. So we have cube root of 64 is 4 and cube root of r cubed is r. Now that we have the value of r or the common ratio, we can now easily find the value of a sub 2 and a sub 3. Let's start with a sub 2. To get the value of a sub 2, we can multiply the a sub 1 times r or the common ratio. So we have 3 times 4 equals 12. The value of a sub 2 is equivalent to 12. Since we have the value of a sub 2, we can now find the a sub 3 by multiplying the a sub 2 to its common ratio, which is 4. So we have 12 times 4 is equal to 14. Therefore, the geometric means are 12 and 14. That's all for today. Happy learning!